So in today's session, we are going to discuss about relationships, and we will see what exactly the relationships and why should we go for associations among the two objects in Salesforce, and what is the need of mapping the association between the two objects, and why can't we store the complete business data within a single object. If I'm storing the whole business data within a single object, then what kind of problems will get arised? And how can we solve those problems with the help of by splitting the data to multiple tables? And upon splitting the data to multiple tables, how can we map the relation between the tables that we will see practically today? And upon mapping these associations, what are the various steps that we used to follow? And what type of associations that we have in Salesforce? What are the various relationship data types that we have? What is the functionality of each and every relationship data type? And once association has been mapped, if the business has been changed, then how can we change that relationship types from one type to another type? We'll see with the practical. Okay. So now it's a bit lengthy topic here. We'll be having some 5 sessions minimum. We'll see each and every feature one by one in detail now. And that too, it's a most important topic as well as part of configurations. Now, so let's come to a small scenario. First of all, let me explain why should we go for associations and why can't we store the whole business data within a single object here. Now, let me explain. For example, I have an organization. For example, I have an organization or a company or a business. So we have an organization. In my organization, we are having 10,000 employees. My total employee strength is 10,000. We have so many branches are available in different locations. In each and every location, in each and every branch, few people are working. Now, so what are the 10,000 people are working in my company? Out of this 10,000 people, 7,000 people are working in sales department, 2,000 people are working in service department, 1,000 people are working in marketing department. Total strength is 10,000 employees. Okay. So in my organization, we have 10,000 employees are available who are working in sales department, service, and the marketing departments because we are offering so many products to the customers. We are offering so many services to the customers. So we have 7,000 people in our sales department, 2,000 people in service department, 1,000 people are working in marketing department. So the total employee strength is 10,000. Now, so still we are keep on recruiting some new employees also because my business is keep on growing. So many new customers are also adding to my organization. So based on the customer's request, we are keep on expanding our business to some other locations also. We are starting some new branches also in new other locations. So to work in those new locations, we need some new employees. Keep on, we are in the process of recruiting some new employees also. Now, in this case, once a new employee has been joined in my company, during the joining formalities, we are collecting so much data from the employee. Whenever we are recruiting a new employee into our organization as part of joining formalities or as part of onboarding formalities, we are collecting so much data from the employees. We are collecting personal details of the employee, contact details of the employee, his educational details, past experience details, project details, family member details, income tax details, bank account details, insurance policies details, provident fund details, reference details. Like that, we are collecting so much data from the employee. So whenever a new employee is joining into our organization, so now we are collecting so much data. Now, if I'm storing this whole data within a single table, what kind of problems will get arise? Okay. Why can't we store this whole employee's data within a single table? If I'm storing the whole data of the employee within a single table, what kind of problems will get arise? Now let's see first. Then we will see, okay, how can we split the data to multiple tables and how to map the relations between these objects. We'll see step by step. Now, in order to store this all this employees data, I would like to create an employee object. Now, I'm having an employee object here. So this is the employee object I would like to have. In this employee object, I'm having so many fields. Employee ID, employee name, is a designation, is a salary, and is a department name, and the location of the department, is the location of the department. Like that, I'm going to be creating so many fields inside the object. This is my employee table. In this employee table, I'm adding so many columns. In order to store this complete employee's data, I'm using this employee object. That means table. In this employee table, I'm storing this whole data over. Now, I'm adding these columns. Employee ID column, name column, designation, salary, department name, location of the department. Like that, I'm keep on creating some more columns also over here. Like, in order to store the employee age, I would like to add one more column. To store the gender, I'm adding one more column. To store the phone number, one more column. Alternative phone number, one more column. Email ID, one more column. Street information, one more column. Previous company name, one more column here. Like that here, I would like to keep on adding some more columns inside my table. So within this a single table itself, I would like to store all the details of the employee. Like I want to store his personal details, contact details, educational details, past experience details, project details, family member details, and then income tax details, bank account details, and all these details I would like to store within a single table itself. Now, in this case, now tell me, if I keep on storing this whole data within a single table, if I keep on adding the columns inside the table, now tell me, do we have any limitations in database that a table can have only these many number of columns, like such kind of limitations? Do we have any limitations? It may be any database, it may be Oracle, SQL Server, DBase, DB2, Sybase, Teradata, Ingress SQL, PostgreSQL, MySQL, MS Access, MongoDB, anything. Do we have any such limitation? Yes. There is a limitation. Whenever we are adding the columns to this database table, in every database, we have a limitation that a database table can have maximum of 1024 columns, not more than that. That is a limitation. So now it may be Oracle also, SQL Server also, they have given the limitation. A database table can have maximum of 1024 columns, not more than that. That is a limitation. When you try to create 1025th column, database won't support. It won't allow you to add that column. So now here in this case here, if I keep on adding so many columns in order to store this whole data within a single table, then definitely at a certain point of time, I will be reaching to 1024 columns here. Because I'm storing PAN number of the customer, passport number also, Aadhaar card number also, okay, like that we are keep on storing so much data here. If I'm storing this whole data within a single table, by keep on adding so many columns, at a certain point of time, I may be reaching to 1024 columns inside the table. In future, when you try to add one more column inside the table, database won't support. Database won't allow. This is the first problem. Okay, this is the first problem. If I'm storing the whole business data within a single table, the first problem is number of columns limitation. A database table can have maximum of 1024 columns, not more than that. If I'm storing the whole data within a single table, keep on we are adding so many columns in the table. At a certain point of time, I will be reaching to 1024 columns. And in future, when you try to add one more additional columns to the table, database won't support. This is the first problem over here. Okay. So upon storing the whole business data within a single table, the first problem is number of columns limitation that a database table can have 1024 columns max. Okay. That is the first problem. Next, second problem here. Now, let me explain the second problem. For example, I'm storing some employees' data in this table. I'm storing some employees' data. First employee ID, some E1001. This is the employee ID here. Name, some Praveen Kumar. Designation, he is a sales manager. Salary, some 25,000. Department name, sales, which is in some Hyderabad location. This is the first employee details. Second employee E1002. His name is some Kishore Kumar. Designation marketing executive. Salary 12,000. Department marketing, which is in Mumbai. E1003. His name is some Rakesh Tripathi. Designation, he is a service executive or service engineer. His salary is some 16,000. Department name service, which is in Bangalore. E1004, his name some Abhishek Verma. Designation, he is a service engineer. His salary is 17,500. Department service, which is in Bangalore location. E1005, his name is some Anil Kumar. He is a sales executive. 13,000 is a salary. Working in sales department, which is in Hyderabad. E1006, his name is some Abhinav Sharma. He is a sales executive. Salary 14,000. Department is in sales. which is in Hyderabad location. Like that, keep on, we are storing this all this data, 10,000 employees data I'm storing in this table. Here I have created 6 records here, like that, 10,000 records I'm storing in this table here. Now, so whenever I'm storing this all the 10,000 employees information in this table, now tell me in few columns some values will be keep on repeating, right? Yes, let's see. Come to this department name over here. Department name sales. In sales department, how many employees are available? 7,000 people are available here. Okay, we have 7,000 people are working in sales department. So now for 7,000 employees records, department name will be keep on repeating like a sales like that here. That means 7,000 times this name sales will be keep on repeating. Now, in service department, how many employees are available? 2,000 employees. 2,000 times this name service will be keep on repeating service like that. In marketing department, we have 1,000 people. So 1,000 times this name marketing will be keep on repeating over here. Now, that means what? In this case, whenever if I'm storing the whole data within a single table, in few columns, this department name will be keep on repeating automatically here. Now, here also in the location column here, we have the sales departments only in Hyderabad location. So Hyderabad will be repeating for 7,000 times. Marketing department is only in Mumbai. The Mumbai will be repeating for 1,000 times. And the service department is available in Bangalore. It will be repeating for 2,000 times. Now, suppose for example here, if I am adding this column country, if I am adding this country name over here, now country will be what? What is the country name for this one? India. How many times India will be repeated? 10,000 times will be repeated over here because all these locations are from India only here. So 10,000 times the country name will be keep on repeating. That means whenever I'm storing the whole data within a business single table, the second problem is redundancy. Redundancy means duplication. In few columns, the same values will be keep on repeating again and again and again. That means a duplicate data will be storing in few columns over here. Now, even though the value may be same, value may be different, upon storing this data inside the database, it will occupy some memory, right? Yes, definitely it will occupy some memory. In order to store this department name sales, the 7,000, it is 7,000 times it is occupying some more memory. To store the department name service 2,000 times, it is occupying some memory. To store the country name India 10,000 times, it is occupying some memory. That means if I keep on wasting the memory to store the same data repeatedly again and again and again, then most of the memory space will be consuming by this particular values itself. Most of the memory will be consuming by this particular duplicate values itself. Because of that, it will be killing my storage space. We can't store much data inside that. Definitely, it will be impacting on my application performance. So this is the second problem here. If I'm storing the whole data within a single table, the second problem is redundancy problem. Because of that, it is going to be causing the performance issues also. Okay. Now, next one here. Now tell me, for example, assume that here I'm having 1,000 columns. Assume that in my database table, 1,000 columns. Database is having the limitation of 1,024 columns here. As of now, I'm having only 1,000 columns. Are there still 24 columns we can create additionally in future if I require. As of now, we have 1,000 columns are there inside my database table. Now, whenever we are creating a new record inside this table, when I click on employees tab, okay, inside my user interface, when I click on this new button, a form will be getting opened, right? In that form, how many text boxes will be visible? 1,000 text boxes. Because that already we know in our starting classes, what are the columns inside this particular database table? These columns are visible on the screen in the form of text boxes, in the form of tick list controls, check boxes, it is visible. Like when you go to the account object, whatever the name text box, rating, industry, annual revenue, whatever the fields are visible on the screen, those are nothing but what? fields of your object, columns of your object. So in this table, I have 1,000 columns are there. These 1,000 columns are visible as 1,000 text boxes on the screen. So in order to create a single record, we have to fill up the data in 1,000 text boxes on the screen. Now tell me, in this case, to enter the data in 1,000 text boxes, how much time it will take? Minimum 2 hours of time. 1.5 hour to 2 hours of time we need to spend to fill the data in 1,000 text boxes. Suppose for example, today a new employee is joining into my organization. We have collected this employee's data. I'm filling up the data inside this 1,000 text boxes. I spent almost 2 hours of time. I have entered the data in all the 1,000 text boxes. Now, when I about to click on save button, suddenly my system has been shut down because suddenly power went off. So I don't have any battery backup for my system here. My system has been shut down. When I, after 5 minutes, power restored here, power has been came back. Now then I have rebooted my system. When I go to that screen back, will you able to see the previously entered data in all the 1,000 text boxes? No, the data will be lost. So then what we have to do? Again, we have to re-enter the data here. That means my previous 2 hours of entire effort is waste. My data is lost. Again, we have to spend again 1.5 hour of data, 1.5 hour of time to enter the same data again and again and again. Do we have any guarantee that in the next 1.5 hour, power won't went off? No. After half an hour, if system has been shut down again, then again my whole data will be lost, my effort will be lost. So this is the problem here. That means whenever we are managing the data inside the object, it will be causing so many issues. It will take more time to fill the data in all the text boxes as well. Now, these are the four major problems are available upon storing the whole data within a single table. Whenever if you are storing the whole business data within a single table, it will cause four major problems. First problem is number of columns limitation. Second problem is redundancy. That means duplication of data will be getting arised in few fields. Third problem is upon managing the data, it is causing so many issues. Fourth one, it is causing performance issues also over here. These are the four major problems will be getting arised. Now, these are the four problems are available if I'm storing the whole business data within a single table. Then, how can we avoid this problem? In order to avoid this problem, as part of this databases, they have given a feature over here. They have given a feature called as normalization. In order to avoid this kind of problem, we are using the help of a feature called as normalization. Then what do you mean by normalization? Normalizing means what generally? Normalizing means splitting, dividing, or decomposing. So in this case here, what do you mean by normalization? Normalization is used to, instead of storing the whole data within a single table, because it is causing so many problems for you. So don't store this whole data within a single table, split the data to multiple tables. Like personal details into separate tables, contact details into separate table, educational details into separate table, past experience details into separate table, bank account details into separate table, family member details into separate table. Like that, whatever the data you are going to store, split this whole data to separate tables over here. Okay, now in this case, whatever the data that we have inside the table, we are splitting the data to separate tables. In this case, there is a principle, there is a consideration that upon splitting the data from one table to multiple tables, please make sure that your data should not lose. Even one character also, even one digit also should not miss. Because that single digit, that single character will decide the credibility of your organization in the market here. Now, so in this case here, whenever we are splitting the data from one table to multiple tables, please make sure that data should not lose. Okay, now for that one, they have given this feature normalization. What do you mean by normalization? Normalization describes non-loss, decomposition of data into different tables. Normalization describes non-loss decomposition of data into different tables. That means okay. So now whenever we are splitting the data into the single table, it will cause so many problems, so that don't store the whole data within a single table, split the data to multiple tables without any data loss. Okay, now in this case here you can raise a question, sir, whenever if I'm splitting the data to multiple tables, I don't want to lose even a single character also, even a single digit also, then what kind of precautions I would like to take care of? In this case, as part of this database, they have given a feature called as normal forms. Normal forms. So what do you mean by normal form? Normal forms are nothing but the principles or standards or the guidelines, okay, which we have to follow upon splitting the data from one table to multiple tables. Whenever we are splitting the data from one table to multiple tables, we need to follow certain principles or certain standards or the guidelines or the rules. Those are called as normal forms. Now, so in this case, as part of database, we have so many normal forms are available. Like we have first normal form, second normal form, third normal form, boys card normal form, fourth normal form, fifth normal form, joint key normal form. These are the various normal forms are available. First normal form, second normal form, third normal form, boys card normal form, fourth normal form, fifth normal form, and the joint key normal form. These are the various normal forms are available. These are the various principles and the rules and the conditions we used to follow upon splitting the data from one table to multiple tables to avoid the data loss. Okay, now, so in this case here, whenever we are going to be building any project also, it may be related to Java or .NET or SAP or wherever, upon building the project, for every project they're designing the database first, because database is the heart for every application. So whatever the data you are going to store, the whole data will be storing in the database only here. So the database is the heart for every application, so that we have to design the database very carefully. In that case, whenever we are designing any real-time database or any real-time project, then whatever the projects we are going to build, for each project, whatever the database we are going to design, the database should support minimum third normal form. Each real-time project database should support minimum third normal form. Now, so now in this case here, okay, now in this case, sometimes we are dealing with some billions of records or some millions of records also when you come to some large enterprises. Like when you go to the banking, for the bank, they might be having some millions of customers. Every day they're doing some crores of transactions also. Billions of transactions also they will do per day. It may be banking or finance, insurance, healthcare, pharmaceuticals. When coming to these kind of organizations, they are getting some millions of records and billions of records per day. In that case, how can we manage those kind of large amount of data? In that case, to manage this kind of bulk amount of data, the people are using some tools called as a data warehousing tools. By using data warehousing tools, we can able to manage some bulk records also very efficiently. So now in that case, we have so many data warehousing tools are available, like as business objects, Cognos, Informatica Cloud. Like that, we are having so many tools are available in IT industry, which we can use to manage that millions of records or billions of records as part of large enterprise organizations. So now in that case, whenever they are going to maintaining or managing some billions of records, they have to take care of some more principles, more standards, so that each and every data warehousing tool, Each and every data warehousing tools, the database should support minimum fifth normal form. That means they need to follow more standards. They have to follow more principles, more precautions to avoid data losses because they're dealing with some millions of records. If something went wrong, this whole millions of records will be lost. So in that case, it will be impacting on their business. Their business will be getting collapsed. For that reason here, for every organization, data is asset. Data is asset for the organization, data is asset for the business. Losing the data means losing the customer, losing the business, losing the revenue, losing the profit, losing the credibility also in the market. So that here, always you have to protect the data from the unauthorized people. So now here in this case, we need to take care of some more precautions upon splitting the data from one table to multiple tables when coming to the large enterprise organizations. So that here, when you go to the data warehousing tools, they will be following that minimum fifth normal form over here. That means they would like to follow more standards. Okay, understood the concept here now. So in this case here, what we need to do, whatever the data we are storing inside our database tables, don't store the whole data within a single table. Better to split the data to multiple tables here, so that we can manage the data in terms of small tables will be very easy. Managing a big table is very difficult. Managing small tables are very easy here. Okay, now in that case, don't store this whole data within a single table, split the data to multiple tables also. Then, how can we split the data to multiple tables? Now, let me explain what kind of steps that we used to follow. Now, let me explain over here. Now, come to a small general scenario. Assume that in my hometown or in my hometown or in Hyderabad, I have some open land. I have some space, I have some open land is available. In that particular space, I want to construct a house. Now tell me, whatever the space that we have, that complete space you would like to construct as a single room? No. We are not constructing the whole space as a single room. Whatever the space that we have, that space I'm dividing into the various small portions. Like as some space into kitchen, living room, and then hall, and then bedrooms. Okay, like that, we are splitting that whole space into different small partitions. Why? In order to accommodate our household items very efficiently. To manage our household items, whatever the items that I have in my house, we can able to arrange these items in each and every room very efficient. Only the cooking related items I will place inside the kitchen. Common items I'm placing in the hall. Remaining items I will place inside that bedroom here. Like that, we can able to arrange our items very efficiently also, so that whenever if we need an item, directly we can go to the place we can use it here. That will be very easy to manage. For that reason, we are splitting this whole data to separate tables also. For that one, whatever the table that we have right now, this table data I would like to divide into small portions over here. Then how can we split? Now let's see. Now this is my table here. In this table, we are having this six columns are available. In these six columns, in these last two columns, the data will be keep on repeating. Department name and the location columns. In these two columns, the data will be keep on repeating again and again and again. So whatever the columns are available in which the data is keep on repeating, make those columns as separate. Make those columns as separate. That means split the data into a separated table. Split the data into separated table. Now, department name and the location over here. Split the data into a separated table. Now, this is the table that we have. So now, in the first table, it is having some details of my employee, some details of the employees available inside my department table here. In this department table here, what we have only department name and the location over here. But in this case, department name is keep on repeating sales, and the department name service also repeating over here. In this case here, in order to recognize each and every department, I would like to allocate a unique identification name. I would like to allocate one unique identification ID for each and every department. Why? Because suppose for example, right now we have the sales department only in Hyderabad. In future, if I'm starting one more sales department in Chennai location, at that time, how can we recognize the department based on name? Here also sales, here also sales. But this is for Hyderabad, this is for Chennai. How can we recognize the department based on the name? It will be very difficult. For that reason, for each department, I would like to allocate one unique identification number that is called as a department ID. I would like to allocate a unique identification number for each department here. Now this is the department ID. Department ID. For this department, I would like to allocate this ID here. For the sales department, I'm allocating D401. This is the department ID. For marketing department, D402. For the say service department, D403 over here. Now the remaining values will be repeated values here. I would like to eliminate. So whatever the duplications are available, I would like to eliminate this kind of duplications over here. Now, so this is the table that we have. So now this is my department table that we have right now. For this table, I'm giving the name as department. Understood the concept here? Now, some data is available in employee table, some data is available inside my department table here. That means whenever we are going to be generating a report related to the employee, we need to collect the employee details, we need to collect the corresponding department details to how to generate a report over here. Now, in that case, how to map the relation between these two? How can we map the relation? So now my data has been split to multiple tables over here. Some part of my employee details are there in employee table. Some part of this employee details are available in department table because these departments are available here in which the employees are working. So now in this case, how can we map this relation between these two tables? So whenever we are mapping the association between the two tables, we have to follow two simple steps. Okay, upon mapping the association between the two tables, upon mapping the relation between the two tables, we have to follow two simple steps over here. Now, in this case here, let's see. Whatever the two tables that we have between which you would like to map the association, we have to follow two simple steps. As a step one, identify the parent object and child object. Whatever the two objects are available between which you would like to map the relation, from these two objects, which object is parent, which object is child. Identify the parent object and child object here. That is the step one. This is the most crucial step as part of relationship. If you are selecting this wrong object as parent or wrong object as child, the whole functionality will be wrong. That's what here we have to choose the right object here. Do the analysis, identify the functionality, analyze the functionality, check how the data is going to be flowing. Which data is dependent on what, based on that we have to decide which one is parent, which one is a child object. But we don't have any such rules inside the IT industry, like if the table name is starting with this character, then it will be parent table. If the table name is starting with this character, this will be child table. We don't have any such rules. That is purely depends upon your business requirement. It purely depends upon your analysis here. We have to decide which one is parent, which one is child. Now come to my scenario over here. I have these two objects, employee object and the department object. Now tell me from these two, which one is parent, which one is child now. Employee is what, department is what?
Employee is parent of
is a parent, department is a child.
Department is child.
Analyzing that, okay, before analyzing this one, let me give you one small point here for your easy identification. mapping the relation between the two objects. Okay, mapping the relationship between the two objects in any database, including Salesforce, including Oracle, SQL Server, any database, whatever we have, any industry here in IT industry. Mapping the relationship between the two tables are nothing but exactly similar like as mapping the relation between the two human beings in the real world. In real world, between the two human beings, whatever the way we are mapping parent and child, similar passion we have to map the relation between these two also. Now tell me from these two, which one is parent, which one is child now?
Employee is a parent, department is child.
Department is parent, employee is child.
Department might be parent and employee might be child.
Department is what? Parent. Why parent?
Because
What is the reason?
department has got more number of departments and then each department has got multiple employees.
Now tell me here, for example, when you go to this real world, we are having parent and child. Now tell me, for one parent, how many childs we can have? Only one or multiple?
More than one. It could be
For
more than
one
one.
parent, how many childs we can have?
Multiple.
Only one child?
Multiple.
No, two
It could
childs
be more
also,
than
three
one.
also, four also, 10 also, n number of, no limitations at all. A parent can have n number of childs. Now tell me here, department is what? Employee is what?
Employee is parent and department is child.
Parent.
Why department is child? What is the reason behind this? Okay, why did you choose this department as okay child? What is the reason behind this? Okay, departments may be having a number of okay. One employee belongs to how many departments?
The
One
department is
department.
parent.
In one department, how many employees are there?
One department.
Multiple. That means what? Department is
Department
what?
is parent.
Parent. Employee is child.
Child.
Okay, that's what I told you. Mapping the relation between the two objects means mapping the relation between the two human beings in the real world. Same concept, no change at all, nothing different. Concepts are real world concepts only. Now, in this case, when coming to the parent, a parent can have 0 childs, 1 child, 2 childs, n number of childs also. Here also we have employee and the department. An employee can work in only one department, but in one department we can have n number of employees also. One child can have only one parent, but one parent can have n number of childs also. Now, based on that assumption, we have to make this a department object as parent object. Department object is a parent. Because in the real world also, if you want to get a child, first of all, we should have a parent. If there is a parent, then only child. If there is no parent, no child. Here also, if there is a department, then only employee. If there's no departments, no employees at all. Now here in this case, we are making this employee object as child object here. Employee object is a child. Clear? Now, analyzing this data will be very, very important. Identifying parent and the child objects are most important as part of relationships. Okay? So that here, analyze the data first. Think about this data first here. Then only we can decide which one is parent, which one is a child. Okay? Now, this is a step 1. As a step 1, okay, we have to identify the parent object and child object here. Here we are selecting this. Department object as parent, employee object as child. Next, this is a step 1. As a step 2, map the relationship between the objects. Map the relationship between the objects here. Then how to map the relation between the two objects here? Okay, now let me explain. For example, come to a small scenario. Assume that I'm going to my home. I'm going to my home. Okay, I'm going on the road here. Okay, I'm on the way to go to my home. So now in front of me, two people are passing here. Okay, two people are passing in front of me on the road. Now, just by looking into those two people itself, we can guess some relation here. Whether these two are father and son, mother and daughter, brother and sister, we can guess some relation. How? Based on what?
Their body
Hmm.
language.
Their
No.
relation.
Based on what? Based on some similarities, like based on face cut, eyes, nose,
Looks.
color, height, looks, and then because of their habits also. Okay, so based on that, we can guess some relation. These two are father and son, mother and daughter, brother and sister. Okay, we can able to guess some relation because of some similarity as well. Based on that similarity, we can map a relation between those two people. Like the similar way, if you want to map the relation between these two objects, we need a similarity over here. Okay, we need a similarity here also. These two are what? Objects. Object contains what? Fields. So here we need a common field over here. Okay, common field. Because when we go to the father and son, they may be having some similarity, like as eyes may be similar. Okay, the looks may be similar. Okay, color may be similar, height may be similar, lips may be similar. Like that here, there are some similarities. Here also, we need a similarity here also. Between these two objects, we should have some similarities between these two objects also over here. Now, then how can we do that? Okay, now let's see. So now in this case here, we need a common similarity between these two people over here. Now, that is nothing but we need to create a common field. Okay, we should have a common field. Where we need to create that common field? In the parent or in the child? Okay, now let's see. So now in this case, whenever we are mapping the relation between these two people over here, we need a common field. That means a similarity is required. That similarity we need to create where? In the parent or in the child? Now, in this case here, that means what? We need to map the relation between these two objects. Now, tell me, upon mapping the relation between these two, from where to where we need to map? Parent to child or child to parent here? We need to
Parent
map
to
the
child.
association from where to where? Parent to
Parent
child. Why?
To child.
because
Parent to child.
Parent to child or child to
Parent
parent?
is the one.
Hmm.
One
The
parent
parent is
has
the one. The child is the multiple. Like one or two children like that.
Now, in this case, let's see. So, whenever we are mapping the relation between, the two objects, always we have to map the relation from child to parent. Okay, child to parent, not from parent to child. Let me explain some general examples. In the real world, also, always we have to map the relation from child to parent. How? Let me explain. For example, today a new baby has been born. Okay, today a new baby has been born. It may be baby boy, baby girl, whatever, anything. The new baby has been born. So now this baby is acquiring so many properties from the parents, right? Yes. Just by looking into the baby itself, we can guess their parent here. Like as we are keep on comparing here, the baby is looking like as father. Baby is looking like as a mother, because eyes are looking like as father, face is looking like as mother, color is looking like as father, lips are looking like as mother. That means what? We are relating this baby with their parents here. That means we are mapping the relation from child to parent over here, because child is acquiring so many properties from the parents here. It may be eyes also, looks also, color also, face cut also, habits also, anything. The child is keep on acquiring so many properties from the parent, so that here we need to map the relation from child to parent over here. Now, for example, whenever we are going to your relative's house first time, how they will recognize you? Because of your parents. Okay, they will identify, oh, he is son of so and so, or she is daughter of so and so, or wife of so and so. That means they will recognize you because of your parents here. So whenever you are filling up any application form also, it may be bank application form or job application form also, we are writing the details, some Ramesh Kumar, son of so and so Pawan Kumar here. That means what? I am describing about myself by giving the details of my parent because they will recognize me because of my parent over here. In my name, whatever the surname that we have, that is coming from my parents only here. So now here in this case, what will happen? So now always we have to map the relation of a child with the parent, not from parent with the child. Okay, so that here upon mapping the association between the two objects, always we have to map the relation from child to parent, not from parent to child. Not only in Salesforce, we can take any database also in the IT industry, same formula, same standards, no change at all. It may be Oracle, SQL Server, MS Access, MySQL, wherever you go, same formula. Always we have to map the relation from child to parent over here. Now, in that case here, how to map the relation? For example, this is the parent over here. Okay, like parent is having some ID, parent is having some name, location. Now we are having the child. Now this child is related to this parent. How do we know? For that one, we should have a surname field. In the surname field, we are adding what? Parent records name over here. Okay. Now, like the similar fashion here, we need to create this surname field. This surname field is mapping the relation with your parent. This surname field is nothing but your relationship field over here. That's it. Inside the child object, we have to create a field. Now, when you go to the database, if anybody is aware of database concepts, Oracle, SQL Server, wherever you go, here also there you creating one field in the child object that is nothing but foreign key field. That foreign key field is nothing but relationship concept in Salesforce. That's it, nothing else. Okay, foreign keys are always creating on child object, which will be referencing the parent object primary key automatically here. Okay, so here also we are going to be creating a field. Then how to map the relation from child to parent? Upon mapping the relation from child to parent, just we have to go to the child object, create one field. You know how to create the fields inside the object over here. Now go to the child object, create a field. Upon creating the field, we have to select the data type, right? Yes. As of now, we have discussed 20 data types here. 19 data types we have discussed initially, and then recently we have discussed one more data type formula also. 20 data types we have discussed. And I told you we have total 25. Still 5 data types are left. Now those 5 data types we are discussing in relationship topic here. Okay, now, so now here in this case, we are having the relationship data types are available. Upon creating this field, we have to select any one of the relationship data type. Now, in this case here, we have to create a field in the child object. In order to map the relation between these two objects, we have to create one additional field in the child object. Simple concept here. Relationship concept means simply 2 steps. As a step 1, identify parent object and child objects. That is step 1. As a step 2, silently go to the child object, create one field. Okay, go to the child object, create one field here. This is a field. I'm creating like some department ID. Because in which department this employee is working here. I'm creating this field. Upon creating this field, then select any one of the relationship data type. Select any one of relationship data type here. Now which will be mapping the relation of this object with its parent over here. It will be mapping the relation with this parent automatically. That's it, over. Simple concept over here. Okay. As a step 1, identify the parent object and the child object. As a step 2, go to the child object, create a field by selecting the respective data type in order to map the relation. In this case here, as part of this relationship data types, Salesforce provides 4 relationship data types over here. Salesforce provides 4 relationship data types. Excuse me. Salesforce provides the below 4 relationship data types. What are those 4 relationship data types? Now let's see. First one, lookup relationship. Excuse me. Third one, master detail relationship. Fourth one, hierarchical relationship. These are the 4 relationship data types are available in Salesforce. Whenever we are going to be creating this particular relationship field inside the child object, select any one of these 4 relationship data type. In which scenario, which data type we have to select, we'll see this concept over here. Because each data type is having its own rules, its own principles, its own functionalities. Now, let's see. Come to the scenario now. Now, Praveen Kumar is a sales manager. He is working in sales department in Hyderabad. Then what it will store now? What it will store? Surname.
D401.
D401. Okay, because this is the D401 is the ID of sales department here. Now, Kishore Kumar is working in marketing department. What it will store now? D402. Rakesh is working in service department. What it will store? D403. Abhishek is working in service department. What it will store? He is working in service department. What it will store?
D403.
403. That means what? This is the parent record ID. That means that these two childs are belongs to same parent here. That means parent is one, childs are multiple. And then Anil Kumar, he is working in sales department here. D401. D401. Now, Abhinav Sharma is working in sales department here. D401. Like that. It will be storing this information here. So now, whenever we are storing this parent recorded child recorded data, along with the child's data, we are storing parent record ID also to indicate this child is belongs to so and so parent over here. Clear? Understand the concept here? Now, these are the 2 simple steps are available as part of relationship. Whenever we are mapping the association between the 2 objects in Salesforce, we have 2 simple steps are available over here. As a step 1, identify the parent object and the child object. Okay, identify the parent object and child object over here. That is a step 1. As a step 2, go to the child object directly, create one field by selecting any one of the relationship data type which will be referencing to the parent object over here. That means select that parent with which you would like to map the relation here. We have to specify that parent object name. It will mapping automatically by default over here. Okay, now in this case, what will happen? Mapping the relation between the 2 objects means mapping the relation between the records available in these 2 objects here. Whatever the records we have stored in parent and child objects, these records has been related here. Now, sales department in Hyderabad is the parent record, and then these records are child, like as Praveen Kumar is a child, and then Anil Kumar is a child, Abhinav Sharma is a child here. These 3 are the child records for the parent record. So, mapping the association between the 2 objects means mapping the association between the records available inside these 2 objects. Okay, understood this concept over here? Now, this is how we need to map the associations between the 2 objects in Salesforce here. Okay, then how to map the association between the 2 objects, we'll see from tomorrow onwards. Because the topics are a bit lengthy here, tomorrow we are going to discuss about lookup relationship. Lookup relationship topic will take minimum 2 hours over here. How to map the lookup association, what kind of behaviors it will provide, everything we'll see one by one. Don't miss the tomorrow's session here. If you know the lookup association functionalities perfectly, remaining relationship topics functionalities will be very, very easy for you here. Nothing else. Okay. If you know one relationship type direct, okay, very clearly, remaining relationship topics functionalities very, very easily you can understand. Because some little similarities will be available, some little bit changes are also available here. Okay. Now, understood the concept here? So from tomorrow onwards, we'll see the concept of relationships features here, how to map the associations, we'll see with the practical. But we require these objects over here. Now, already during the previous sessions, I showed you some objects, hiring manager object, position objects we have created. Have you created those objects? Those objects are required because I would like to show that examples on those objects only. If you do the practice of lookup association perfectly, then only remaining will be very easy to understand, or else it will be looking like as a bit typical for you. Okay, so that here create those objects first, be ready with those objects by tomorrow. Tomorrow I will show you how to map the association between lookup associations. Okay, thank you.
Thank you, sir.
So
Thank you all.